Swayam Prabha, free DTH channel for education.
Now let's come to the differential equation now. Okay, so we have defined f of x equal to x square. Then we found f dash of x equal to 2x we can find, and then you can, if we ask the reverse question, that's kind of inverse problem, we may get infinite number of answers are there. So it is not necessary in general you will get a solution, or it may not have a solution also, or it may have infinite number of solutions will be there. Okay, so now what we are going to do, we are going to find what is a differential equation. So for differential equations, first question is, first you need to understand what is an equation is. Okay, first you need to understand what is an equation is. So what is an equation? Equation is nothing but a statement. Okay, it's nothing but a statement that the values of two mathematical expressions are equal. Okay, it's nothing but a statement which is going to say the two mathematical expressions are equal. For example, I can say x plus 4 equal to 5. Okay, that means this is an expression. So the left hand side I have an expression, right hand side I have another expression. Or I can put something 5 plus 5, left hand side I have an expression, right hand side I have an expression, and then I can say these two are equal. So this is called an equation. So this is the important thing. If I have equality, okay, if it is an equation, I should have an equality. If it is not having equality, if you have something like inequality, like less than, greater than, etc., then we say that is an inequality means to say. Okay, so the equal sign indicates this sign indicates the equal sign. Okay, now differential equation means what? So if we are having like this is called algebraic equation, I can say, because this is algebraic equation, or you might have studied in the school days, the algebra, etc. So this is algebraic equation, you can say. So in the case of differential equation, what I have is that instead of this x, suppose I involve some equation, okay? Let's say dx by dt plus 4 equal to dy by dt. Okay, so this is that. So in this case, I can say this is a differential equation. Okay, this is called differential equation. It involves unknowns. Okay, the contains derivatives of an unknown function where x and y are unknown. Similarly, I can define something like dy by dx plus 4 equal to 7. Okay, dy by dx equal to 7y plus 4 equal to 7y, something like this. If I write that, then this is called a differential equation. Same thing, if I write something like uxx plus uyy equal to 0, this is an example for ODE, this is an example for PDE. Let's compare the ODE and PDE. So, what is an ordinary differential equation is that an ordinary differential equation is an equation that has one or more several derivatives. Okay, one or several derivatives of an unknown function with or without the unknown function. With or without the unknown function means, for example, here I have 7 by if I consider like dy by dx plus 5 equal to 0. Okay, this is a just involving without. So here I have without y. Okay, y is not involved over there. So dy by dx plus 5 equal to 0 is there. Or I can say like d square. So second order derivative, I can take d square by dx square plus dy by dx plus 7 equal to 0. Something similar to that I can define. In general, I can define something like a function. A function I can define. Okay, it can involve x can be involved, y can be involved, y1 can be involved, y2 can be involved. So these are the derivatives, etc. Yns are involved. Okay, so this is equal to 0. Okay, so this I call it as a ordinary differential equation. Means here y is a function of only one variable. Okay, y is nothing but a function of only one variable. Okay, so in that case, you call it as an ordinary differential equation. Okay, so this equation I call it as an ordinary differential equation that is equal to 0 sign is there. So it is a ordinary differential equation. Okay, so which is usually here we usually take y of x if the independent variable is x. So we say x is the independent variable and y is dependent variable. Means the dependent variable y is a function of x alone. Means only one input you are giving and you are getting an output out of it. Okay, so that is called the ordinary differential equation. Whereas if we go for the partial differential equation, in that case, okay, it can be either vector valued or possibly it can be like 2 or more variables will be involved. So if I have something like u is a function of x comma y, okay, u is a function of x comma y comma z, etc. is there, then we say this is a function of more than the two variables are there. If I found a similar kind of relations, okay, if I find a similar kind of equations in this case, so in this case it is going to involve something like I can say, for example, if you take the partial derivative, so in that case I can say x is there, y is there for two variable. So ux is going to be there, uy is going to be there, u is going to be there. So this is called partial derivative. Okay, first order I can say, first order partial differential equation, first order PDE we say. Similarly, you can define something like f of, yeah, suppose similarly I can define something like f of x comma y comma z comma ux uy uz u equal to 0. I can define. Same way I can define two-dimensional one. I can define f of means second order I can define f of x comma y comma uxx uyy uxy uyx ux uy u equal to 0. Okay, something similar to that I can define. So these are all called PDE. Okay, these are all called, so these are all called PDE. Okay, these are all called PDE, but this is called ODE. Okay, so here y is a function of only one independent variable. Here u is a dependent variable and two inputs are there. Okay, if multiple inputs are there, and for that if you are finding this differential equation, okay, the derivatives etc., that is called partial differential equation. Only one independent variable is there, that is called ordinary differential equation. So once you come for the engineering problems, some of the experiments you might have seen, some of the experiments may be having, you need to keep one variable as constant. So, sorry, you need to keep only one input and then you have to observe what is the output is going to come, and then you will list out what all the variables is going to come, and then you will study something. In some of the experiments you might see, you will have multiple inputs which is going to play the role for you. Okay, multiple inputs are going to, you are going to mix many parameters together and then you are going to find some relations. So in that case, you have to deal with the partial differential equation, because one you can keep it constant and you can study, or another one you can keep it constant and you can study. So you can convert that PE to ODE and then you can solve it also. That is also possible. So these are the things which you need to understand. Once you are solving the differential equation, okay, ordinary differential equation and partial differential equation, two types are there. So if you have ordinary differential equation, means your experiment or your data or your output is going to be a function of one variable, and for that you are going to derive some mathematical model which we derived in the last 3 lectures. So that is going to be there. If it is going to have multiple things, then you are going to have partial differential equation is going to come. Now ODE, so there are some examples I can give. So dy by dx equal to, so I have given dy by dx equal to 5 e power 5x. Okay, similarly d square by dx square, or x square d square by dx square plus x into dy by dx plus 5y equal to 0. So these are some of the examples for differential equation. Similarly, we have seen uxx plus uyy equal to 0, uxx plus ux plus uy equal to 0, or uxx plus uy equal to 2u. These are all some of the examples for terms. Okay. Now what we are going to deal? We are going to deal with first order ODEs alone. So in this class we are supposed to solve only the first order ODE. So let us see the first order ODEs. So first order ODEs of this form. So if I say first order ODE, that means it is going to be of this form: f of x comma y dash is going to be there. Okay. So only this is going to be there. So it means it's going to involve equation which is going to involve x is going to be there, y is going to be there, y dash is going to be there, and some constants are going to be there, and some linear expressions are there. So that is called the first order ODEs. Okay. So for example, the example which we have seen, murder in a hotel, where we have seen that the hotel room number, etc. So where we define the temperature, okay, temperature of the tea kettle at any given time. So that is, we are going to measure the temperature with respect to time. So time is my input variable, temperature is my output variable. So T of T, I am going to denote temperature of the tea at any given time I am going to measure. Okay, that's one I am measuring. And some constants are given like TH equal to room temperatures are given. Now what we are going to do is that we are going to see, we already derived this as Newton's law of cooling. So Newton's law of cooling, what we have is that we have a, so this one also we have derived the cancer treatment one, which we have explained the mathematical model. So same thing, okay. So this one we have already seen this kind of model. What is it going to come? So this is going to become like your temperature according to the Newton's law of cooling, it is going to become like Tt by d Tt by dt is proportional to T minus Ta, means ambient temperature is going to be there. So depending on that, it's going to come. So I can write this as Tt by dt equal to some constant, proportionality constant I can keep, and T minus Ta is going to come. So this is an example for simple ordinary differential equation. Okay, and then we have some more conditions like we say like initial value problem and initial condition, which we will see little later. Okay, so this is the one which we have T by dt equal to K into T minus Ta. So this is my differential equation. So if I put some condition, so I have a condition like T of 0 equal to 85 degrees Celsius or some constant is there. Okay, some conditions I have given. This I call it as initial condition, and together this I call this as initial value problem. Okay, this problem I call it as initial value problem. Okay, so this we have seen. First order ODEs. Okay, this is the first order ODE because I just involve only Tt by dt. As a implicit form. Okay, this form f of x comma y comma y dash equal to 0, I call it as implicit form. Suppose if I can write this equation as y dash equal to f of x comma y, okay, then this is called explicit form. This form is called explicit form. Okay, this is called explicit form, and this form is called implicit form. Some problems may have implicit way, some problems may have explicit way. So you need to deal that. You can just sometimes you may convert that into explicit form and then you can solve it. Sometimes you may not be able to convert that and then you have to deal with it. Okay, for example, I can rewrite whatever explicit form is given, I can rewrite the equation simply. So if I just if I want to replace this one here, I can just write y dash minus f of xy equal to 0. Okay, then I can just define this as f of x comma y dash. So whenever explicit form is given, you can automatically convert that into a implicit form in this way. But if implicit form is given, it is not necessary that you can convert that into explicit form. For example, I can give an example like y dash square. Okay, okay, you cannot find a simple one, but you can just convert that. You need to do some kind of arrangements, etc. You have to do. You can convert that. For example, I can say y dash square equal to 2xy is there. Okay, in that case 2xy square is there. Okay, so in that case I can say like y dash square equal to 2xy is there, and y dash I got to define like square root of 2xy I got to define. Okay, so in this case, for example, f of x comma y dash is going to be y dash square, or let me put y cube y dash square minus 2x y square is there. Okay, or let me put something different. So 1 by 2. Okay, so in this case you cannot cancel most of things, so you can just do similar kind of things. So this is implicit form I can say, and then you can convert that into explicit form or something different. Okay, so these are all the format available: explicit form and implicit form. Now what we need to do is that here x is an independent variable and y is an dependent variable or an unknown function, which we need to determine. Okay, we need to find what is that. So geometrically, what is y dash? Y dash is nothing but the slope of the curve y of x. Therefore, whatever you give the solution, okay, suppose a point is given. Suppose I give a point x naught comma y naught. Okay, so if I say a solution, I need to define what is the solution means. Okay, if I find a solution, then that solution should pass through the point x naught comma y naught. Okay, that means what I should have. I should have that. Suppose y cross equal to f of x y is given. At x naught comma y naught, it should pass through that. That means y dash of x naught should be equal to f of x naught comma y naught should be there. Okay, so that we call it as a solution passing through them. Okay, the solution passing through them. So we got to define what is the solution. We define that what is the solution means. Okay. Similarly, so suppose this is given. Okay, you have a problem. Okay, explicit form I got given. Suppose I got given y dash equal to f of x comma y, and I got given one more condition: y of x naught equal to y naught is given. Okay, some condition I got given: y of x naught equal to y naught. So in that case, this problem I call it as initial value problem. Means differential equation is given with the condition the x naught is the initial point I got given. So that problem we call it as the initial value problem. Initial value problem. Okay, in general, the ODE with the initial condition is called an initial value problem. So, for example, the explicit problem can define y dash of x, y dash equal to f of x y and y of x not equal to y. Okay. Now, what is the solution which we need to say? Okay. Solution means what? Suppose I have, if I have this one like x plus, as I said, x plus 5 equal to some 7 is there. Then what is the solution of this one? The solution is going to be 2. Okay. So whenever I put 2 here, these two expressions are going to become equal. These two expressions are going to become equal whenever x equal to 2. Same way, once you compare the differential equation, what we need to do is that suppose y dash equal to f of x y is given, I found some y of x. Okay. Suppose I have found some f of y of x. Okay. Or I say, let's say like h of x is found. I found some function called h of x. In that case, what I need to do is that this h should be differentiable because I have y dash. The h should be differentiable. So in that case, I have to find what is my h dash of x. This h dash of x should satisfy this f of x plus h. Okay. So then, also if it is an initial value problem, then we have to satisfy h of x not equal to some y naught should also come. So then I say that this h is nothing but my solution. Okay, that h is nothing but the solution. Means this expression should be valid. If I put h over here, wherever that y is there, okay, I put that h, and wherever y dash is there, I got to put the h dash. That is going to satisfy. Then I can say that that is going to be a solution of the. For example, here I can put in this problem I can put h into h dash square into 2x into y square. I can put, or I can put h dash equal to square root of 2xy. Then we can say that that is going to be a solution. Same way here, if I substitute some t of t is equal to some function over here, this expression should be valid. Okay, that we call it as the solution term. Okay, the values are values of value or values or a function which makes the equation valid is called the solution in general. So in the case of ordinary differential equation, first order ODE, what we are going to say is that h is a mapping from a comma b to r. K is said to be a solution of the equation 7 if h is differentiable in AB and satisfies the equation. For example, here y dash equal to f of x y, replacing y by y dash and y dash by h and h dash, that should satisfy. So in this case, I cannot say it is going to satisfy everywhere. It is going to satisfy only in that interval. A comma b only I can say it is going to be the solution for that problem. Okay, it is not going to be in general. It is going to be. So in some cases, you may require only the AB. You don't require infinite interval to solve the problem. Now, once you find this h of x, you can draw a curve for that because x is an independent variable. So therefore, h of x you can draw it. So that we call it as a solution curve. That h is called as a solution curve. Okay. So for example, let's take a simple problem now. Okay, let's take that. Let's take some simple problem and see how to find that answers for that. Suppose I have a problem. Y dash equal to f of x is there. Okay, y dash equal to f of x is there. Now what we need to do, we got to find the answer for that. Means, see, in general, what is my problem? I am going to consider only explicit ODE. Okay, y dash equal to f of x y is given to you. Okay, so this is the problem given to you, and then you need to find the answers for it. So suppose you have y dash equal to f of x is there. There is no y involved in this one, only x is there. Okay, this f is independent of 1, only f of x is there. So in that case, how do we find the solution for this one? The solution, I can simply find that this is going to be, suppose I have given some y of x naught equal to y naught is also given. Okay, suppose I have given some x naught is given. Then what I can find is that I can find the solution for this one, which I can find it as from the integral I can find. Okay, that is going to become like x naught to x dx plus c is going to give me the answer. Okay, so this one we call as antiderivative. So what is that x naught to x f of x dx is going to denote? This is going to denote me, okay, for a given curve. What is it going to denote? It is going to denote me the area, okay, area under the curve. So f of x is a curve. So for that curve, what is the area under the curve which we are trying to find? Okay, so I have given x naught to x. So if I give a to b, this is going to be a definite one. But we are calculating y of x. Therefore, x naught to x means whenever this x naught is I have given, okay, I can find f of x naught comma. If I give x is here, I got to find integrate from x naught to x, and then I got to find what is the area under this, area under this, area under this. Okay, up to this interval, etc. Plus some constant is going to come because for that also it is going to give the same y dash. Because if I differentiate this one, I'm going to get that y dash is going to become like, it is going to become like f of x, this is going to 0, only f of x is going to come because there is integration, integral and derivative are inverse of each other. Okay, means if you have a differential equation, you can find the, suppose you have a derivative, then you can find the antiderivative of that. Okay, that's what we can. So can you guess the mathematical concept or theorem behind the equation? So this, where C is uniquely determined, y of x not equal to y naught is given. So what is the mathematical theorem behind that is that, so one mathematical concept is that we need to find the area under the curve. Okay, that is the integral definitions. Okay, now what we are going to do, what is the mathematical concept behind the theorem?